In this training video, we will talk about path operations, which are under this menu over here. All these are operations which are applicable to surface macros only. We've already discussed in other training videos the range operations and the splice operations. So in this one, we'll start off with path operations. And the first one which we want to talk about is embed rebar into formwork objects. Now, the idea over here is that we will, let's say we have a surface. So there's a column over here and there's a corbel over there. And let's say we want to apply the surface macro to the top of this corbel. We select it, we right click twice, select the surface, and then show the 2 points for the direction of the main bar. And we get our rebars. Now, if we were to click on any of these rebars, let me turn off the handle so that they don't disturb us. Click on the rebar and set enter. Currently the start and end don't have any end detail on them, but if you were to say to close this segment, something like that, the bars will obviously turn into the corbel. But what if we wanted this end, for example, to not turn inside the corbel, but actually go inside the column and get embedded into a column? But the column is a different object. When we were placing the rebar, we placed it using the corbel surface, and the corbel ID was used, and we did not even mention the column ID. So we're tackling the scenario in which a surface macro has been placed on a particular object, on a particular surface, but we don't want the end condition to just turn within the same object, but we want to embed it into a separate object. That's the question which will be tackled by embed rebar into formwork objects. What it means is embed rebars into other formwork objects. Obviously, it embeds it within itself automatically by default. But if we don't want that, but we want to, as the picture also you can see, the bar is coming out and it's getting embedded into something else. That's the question which this particular operation addresses. So what do we do in that case? The first thing obviously we will do is that we'll go into our surface macro, and the start or the end, whichever one needs to be embedded. Let's say in this case it's the start which needs to be embedded into the column. So for the start one, we'll keep this option of do nothing. For the other one, we can keep whatever option we want, but we'll leave the start at the end of the corbel and not do anything with it. Once we have that configuration, we will go into our path operations and click on this one. If we press the shift key and click on it, we will see that it has its own settings. So obviously the embedment will be applied to the main segment, embed perpendicular to surface, select embedment direction on screen. These are certain detailed options which we can talk about later. But the main option over here is that if you click on this button, the method is by embedment length. The embedment amount is 50 phi. The other ones can also be modified depending on our needs. This particular dialog box has been explained in other videos, but we have this embedment data basically. So once we do the settings, we can go back to the path operations, click on this one, select the surface macro in question, which is the selector rebar, and then it asks for a rebar point. So it wants to know whether you want to embed the start or the end. So since we want the start, we'll basically click on any point close to the end, just somewhere over here, let's say. When we click on that, you will see a little red dot appear over there. So it's selected the right end, not the wrong one. Once you've done that, it asks for select objects to union. So because this is basically a union operation in which the column kind of becomes part of the corbel. So you select the column and then you right click, and then you can select other objects as well. So when you're embedding into other objects, you can select multiple objects and the bar will be embedded into the unioned object. So since there is no other object at the moment, I will just right click again and just do a refresh and finish the command, and you will see that let me just show only this one so that other things are not shown. You see that the bar has now been embedded, which was originally only placed on the corbel, has been embedded into the column. Now, if I go to my, as we've done in the other videos as well, list operations, click on this rebar, selected, it says there's one operation on this surface macro, which is embed rebars into other objects. If I double click on this, you will basically get the same settings which we just had. So if I were to say, make it 75 feet, like that, and say, okay, the embedment length from this point onwards will be 75 times the diameter of this bar. Now, this is just let me just mention over here that if we have this operation, we go inside, we even have this option of reversing the embedment direction. And if we choose that, then you can reverse the embedment direction once it's inside the column. That will depend on the settings. But what this command basically allows you to do is, if we go back in once again, select it, double click on this, it allows you to specify a embedment amount. You can use other methods by you can specifically give a specific amount as well, rather than a multiplier of the diameter. And then it will just extend it as if the original corbel and the column were a single piece of concrete. Now, normally when you say embed this rebar into the column, for example, by using this path operation of embed rebar into other formwork objects, it'll just embed it, it'll hit that point, and it's going to continue embedding in a direction which is normal to the face of the column, which is basically means straight into the column. But if you want, you can go inside this by pressing the shift key, and you can select this option of select the embedment direction on screen. Normally this is turned off and it's automatically done into the column. Basically the bar just extends along its own line. But if you select this one, then what COMOSYS will allow you is to select two points which will give a direction. So let's say I want these bars to go inside and not go straight inside the column, but I want them to turn 45 degrees down, for example. Let's say that is the requirement of detailing. And the amount would be 50 phi or something. So the amount is given over here, 50 phi by embedment length, but the direction of embedment I want to specify myself. So with these settings on, I can now go back into my path operation, embed rebar into formwork objects, select the rebar, select the end, select the column, right click again to say that there are no other objects. But now it doesn't immediately do it. It asks for 2 points. 2 points which will give it a direction. So I can just select this point, for example, and I want a point going 45 degrees down from that. So I can once again hover over this one and say at 0, 50, minus 50. So 0 in the x direction from that point, 50 in the y direction, and minus 50 in the z direction. That's basically giving it a 45-degree angle. And if I press enter, you will see that the embedment which has been achieved now is from that point, it's just taken a direct turn of 45 degrees, and this length is the required length which we wanted of 50 feet. So the diameter is 10, so it should be about 500. So this option allows you to, let me go back in there. If you turn this on, it will allow you to change the direction of the embedment. But like I said, by default, it's just going to go straight. If we increase the number, let's say we go back into the operations, double click on that, and instead of 50 feet, if we make it 100 feet, then it's probably going to hit the end of the column and hopefully turn from there. So it hit the end of the column and it took a turn from that point. Now you can of course reverse the embedment direction. You can make it go down if you wanted to. We've already discussed that by clicking on the reverse embedment direction. By the way, you can also use these check for small angles, and you can give it a limit. And in that case, it will automatically avoid the smaller angles. It will always prefer the larger angle as far as the embedment is concerned by default. So that will allow COMOSYS to take that intelligent decision on itself, because when it does it like this, then obviously there's a chance of, if especially if the concrete around that area is lean, it can cause cracking in the concrete. So you want maybe to use the other direction, but you can tell COMOSYS to do that automatically by checking for small angles. Now let's talk about another case, or rather the next operation, which is embed rebar into other formwork objects through a target surface. So that's the only difference from the first one. This one, in addition, asks for a target surface. And what do we mean by that? So let's say we've got a rebar on this face of the column of the corbel, and we're looking at it from the side. And we want to now embed this end into the column. But we are not on the top surface. So the top surface was directly close to the column, but we want the embedment to like go from here up, turn into itself, hit the column, and then from that point onwards, we want it to go 50 feet or whatever, some number, let's say 35 feet. Now, so we don't want to count, first of all, these initial bends because they're within the object. We only want to start counting the embedment length once it enters the column from that point onwards. So that is basically kind of a summary of embed rebar into other formwork objects through a target surface. So until it gets to that target surface, it's not going to start counting. It's only going to start counting once it crosses that target surface. So how does it work? Once again, you can click on Shift. Once again, you can set a reference direction. We're not going to do that. But inside, you have an embedment length. Let's say it's 35 feet. And you say OK. And now let's try the operation. This one, embed rebar through a target surface. You select the rebar, which has been created by a surface macro. I'm always reminding that all these operations basically work with surface macros. Then you select an end, and then you select the objects which you need to unions. That's the column. Then you right-click and right-click again to show that there are no more. And now it's asking for a target surface. And the target surface needs to be one of the surfaces of the original corbel on which we have the surface macro. And the surface we want is the one at the back, the one which is touching the column. I can't see it from here. So whenever you are in a situation like this where you can't directly see that surface, the trick is to press the control key. And while keeping the control key pressed, it will select the one at the back. It'll skip the one you're directly pointing at. It's going to go one step back. And so now you can see I'm selecting that surface. If I select that one, what you see is, if I just right click now to finish, you see what it has done is, it has done an embedment into the column. It started off from here, it turned within itself, it hit that target surface, and then it embedded. So we asked for 35 feet. So the diameter of this bar is 10 millimeters. So we should have 35 feet should mean 350 millimeters, so that we can check that by measuring the distance from here to here. That's, as you can see on the screen, the Y component is 350 millimeters. So what have we achieved? We've basically embedded a surface macro into another object by not counting the first few turns or however many turns within itself, and only starting to count after it hits a target surface. So this is a slight kind of a variation of the first embedment command. Now in this training video, let's talk about the path operation. In this part of the video, I mean, let's talk about the path operation, which is called divide and or delete rebar from a point. So basically, you have your surface macro, you have your surface rebar, and you want to break it at a point. So let's say you want to break it at this point. There's a point over there. You can actually physically create the point, or you can just snap to some point using direct entry. But if you want to use a proper point, then it will allow you to then later on modify that operation as well. So I'm going to show you that first. So I've created a physical point over there. You can see there's a physical point. Now, what do I mean by breaking the rebar? First, let's try it. Let's go in there, press the shift key to open. So there's this kind of input. Right now, I'm choosing the ID based one, which means I'm going to physically select a point. If you don't want to physically create a point, you just want to break at any point you can snap to, then you will say point based, and then it'll just select a point which you can, anything you can snap to, even using direct entry. But right now we're going to use this one. The rest you can just leave it as it is. Press OK. Now, if you go inside and click on this one, it asks you for the surface macro rebar. You select it, you right click again to say that there's not, you don't want to select any others. And this time it asks for the point, the physical point which you just created. So I'm going to select that point now. And once you select it, it's asking me for a side which you want to keep. So obviously when you break it from here, there'll be two sides, one this side and one on that side. So if I want to keep that side, if I want to keep both sides, I will just say right click at this point. So if I say right click, I don't select the side and right click again to finish, you will see that the surface macro has been broken at that point. Right? So you've created a physical break at a particular point. Now, because I said that the advantage of having a physical point is that you can always select that point, move it, for example, let's move it 250 millimeters up there. And then if I just do a refresh operations on my surface macro, right click again, you see that the point where it broke the surface rebar has been shifted according to the new position of the point. Now I can once again go in and list my operations. See that we've got one operation called divide and delete. We can delete that to do it from scratch. And this time what I'm going to do is I'm going to go back into the command, select the rebar, right click, select the point. And then this time I'm going to show it a side which I want to keep. So I can just select any point on that side or this side. So let's just select this point over here. When we do that, you see that we have physically broken the surface macro at that point, and the rest of it has been deleted. And this will not come back. This is what the operation will do. When we go into the surface macro, for example, press M and enter. If we change the spacing to say 400, right? Spacing will change, but this part of the macro will not be generated because the operation will always delete it. So, for example, you could think of situations where you might need such a thing. So you could have, for example, a column and a foundation, and you put some surface rebars on the side of the column, and then you break it, and then you embed them. But you break it in the middle to create a starter bar kind of a situation, for example, right? So you can keep both sides of that, the one which is continuing into the column and the one which turns into a starter bar. Or if you only want to create the starter bar, then you would do what I just did. You would select one side and say, I don't want the rest of the bar. Once again, if you move that point by selecting it, if you move it to another location, you can of course do these with handles as well when it's not a surface macro. But if it's a surface macro and you want to keep the surface macro for later purposes, and you want the original settings to work every time, then it's a good idea to just make sure that whatever you do through operations, you continue through operations as well. Now, another operation which is very useful when you have surface macros is what we call the generate a starter bar from a rebar. So you already have a rebar through a surface macro, of course, And so in this case, we have this surface macro on the side face of the column. We can press M, enter, and we'll see that the start has this do nothing and the end is to close a segment. So they've basically followed that, but the start is left at with the setting of do nothing. And we want to now generate a starter bar over here, which comes out of the foundation, basically follows the spacing of this one, comes out of the foundation and has a certain overlap. So what we do is, if in the operations, there's this one called generate a starter bar from the rebar. If you press on the shift key, once again we get the settings. You can specify, but you have to go inside and specify it over here, basically. So you specify a certain amount, a multiplier of phi. You can check whether you want the reverse direction or not. Usually with the starter bars, the reverse direction option is more useful. We'll just see that in a second. So we do these settings, okay, and the way it works is very simple. You just go to your generate starter from a rebar. You select the rebar. It asks for a rebar point. So whether you want to generate a starter at the start or at the end. So we want it at the start. So we just select this point like that. And the moment we do that, it asks for a foundation object or multiple objects. So you can select the foundation over there. If there's no other, you can just right click to confirm that, and then once more right click to finish the selection. And you see that immediately these extra starter bars with a certain overlap have been created, and they're going inside your foundation as shown. Now let's do it from scratch. For example, for example, they will follow the surface macro, because if you go inside the surface macro and reduce the spacing to 100, for example, on that surface, you will see that the surface bars or on the face of the column are changed, but also the starter bars are following that the same amount. Now, if you wanted to do another surface macro on this side of the column, obviously you don't, for such simple cases, you're not going to use it. You're just going to use the column, the polygon column reinforcement macro. I'm just showing that if you're doing manual detailing in some for a complex situation, you just select the column, you right click again, you select a face, you show the direction of the main bar. So you just show any 2 points basically. When you do that, your bars are created. So these are the bars on this face now. Once again, we can go inside our operations, generate starter bars, select this one, select the end, select the foundation, right click, and so with a few clicks, you're able to create your starter bars. And that's the purpose of this this particular operation. Like I said, let's just repeat that. All these operations are saved inside the surface macro, and they can be the parameters can be changed whenever you want by double clicking on them. You can change the data over here, and whenever you do that, you just press OK and OK. And if you want to delete the operation, you can just select that operation and say delete, and that particular operation will then be removed from that surface macro. Now, when you generate starter bars into a foundation, obviously the foundation itself will have its own main and secondary bars. And if you just embed it into the foundation, you see that because it goes all the way to the clear cover from the bottom face of the foundation, it's going to clash with these bars. So you want to maybe pull it back a bit, and there are several ways of doing that. One way would be to just go into the operations, which we just did. We created the starter bar, and if we just click on the operation itself, and if you notice that this, when it goes into the foundation and it turns into the foundation, this distance is called offset distance. You can see it over there. And offset distance is given over here. Normally it has a default of whatever the clear cover is, I think. So, but in this case, you want the clear cover plus the diameter of the main bar of the foundation plus the diameter of the secondary bar. Those are, both of them are 10 right now. So that's 70 and plus half of its own diameter. So if you put it at 75, this offset distance, then the operation itself will just bring it to that top. You see that now it's sitting on the orange bars, which is exactly what we wanted. Now you can do the same thing in different ways as well. Right now what we did was we just went into the operation and changed the clear cover from there. But another thing, so let me undo that. So it's back in inside, and now it's clashing again. There's another operation which is in the path operations, which is called the move rebar segment. And this one, as you can see with the icon as well, it basically moves a segment of the rebar, of the surface macro rebar, to some distance which we show it. So if I press the shift key, you'll see that it has certain input methods. I'm going to use the point-based method at the moment because I want to snap to the midpoint of a rebar, and I'm going to give it an offset because the diameter of this rebar is 10, half of it is 5. I'm going to give an offset of 5 from there and say OK. And now what I can do is if I go to my, so it's clashing at the moment, and if I go into my move rebar segment, it turns into this crosshair, the cursor, and you can do a window selection on the segment which you want to move. We want to move this particular segment of this starter bar. So we just kind of zoom in and we do a window selection like that. And when you do, it's going to just select only that segment, if you notice, not the rest of the rebar. And then it asks for a point, and I can just press my control key and click on any point on this orange rebar. Just remember that when you're snapping to a rebar, you're always snapping to the midpoint. So I show it that point, and immediately this segment is offsetted to that point with a further offset of 5. I mean to that because that's what's needed to actually sit on it. And that was if I go into the operations now, into the starters, there's the generate starter bar, and then there's a move rebar segment with an offset of 5, which we just did. So this is another way of doing basically the same thing. Sometimes you have multiple layers, and you want, it's difficult to calculate the exact amount from the bottom of the foundation, and you just want it to sit on top of a particular rebar. So you can, in that case, using the move rebar segment to the top of this bar kind of thing is more useful. Now, another area where you might want to use this would be, for example, in a sectional view. So right now you can see this bar is now sitting on those secondary rebars. Let's say you wanted to move this segment of the main somewhere a bit to the right, but in such a way that it like kind of goes around this rebar over here, this particular one over here. Now we can use the same path operation of move bar segment, and let's click on the shift key as well. So these are the settings. In that case, the setting for the offset would need to be because we want it to sit exactly the way it's sitting over here. If you notice, it has a radius over here, and it's curling around. So the last point on which a rebar can sit is like 1 radius away from that. So if we go in and go into the settings over here and change this to 25, and the reason why I'm saying 25 is because the radius of this 10 millimeter, the bending radius over here is 25 millimeters. How do I know that? Because if I double click on this, the current value is 2.5 times the diameter of the bar, so that makes it 25. So I just change the setting to 25 millimeters, like that. And now if I go into my path operation, move rebar segment, and zoom in and select this segment over there, it asks for the moving point, the point where I want to move it to. Let's say I show it this point, and when I show it immediately, it moves that bar. Now you might be thinking that it's taken it too far, and that's because of the setting. Let's go back inside the operation. So this above and below sometimes becomes a question of trial and error. It should have been below in this case. So we just go like that, and you see that because of the 25 millimeter offset, the segment is perfectly sitting at a point where this bar can perfectly sit at the edge of that rebar. So with that modification, our in the 3D view, we can see that this is how it looks now. We've moved it in such a way that this is now perfect. This segment is moved to that point. So using this path operation of move the rebar segment, we can do things like what we saw. We moved the starter to sit on top. We moved this one to. Sometimes you want to delete these two rebars for some reason, and then you want to move that segment to the whatever the first one was. So in those kinds of situations, you can use this move rebar segment option. Now, we said you would do something like this when you wanted to, for example, delete these last two rebars. How would you do that? If you just remember, in our range operations, we had this conform to a point. So we could just select this one, and the conform point would be this rebar, and we want to keep that side. So that would basically limit the range of that rebar to that, and then normally that's the way we would do it. We would first limit the range, and then we would move this segment to fit that range as well. So all these are possible ways of doing the same thing. Now, the last operation in the, not the last, but the next operation is the mirror rebar segment. This one, basically what it does is whenever you have a segment in which you don't like the direction. So for example, let's say the starter rebar over here, this segment is turned this way, but let's say you for whatever reason you wanted to turn it inside towards the column. So you didn't like the direction in which it was being embedded. And this is usually for the last segment of a rebar. So in those cases, you can use this operation called mirror rebar segment. And the way it works is very simple. It does a multiple selection on multiple segments. So you need to be careful because in one go, you can select many segments and then all of them will be reversed. So sometimes you need to zoom in and make sure you're not selecting something incorrectly. But all you do is basically you click on this one, and then let's say you wanted to turn this back in towards the column. You would just zoom in and do a window selection of this segment. And what will happen is the segment will be reversed. And this is also an operation now. So whatever the surface macro decides, it's going to reverse that direction. This option is available from inside the surface macro as well. But like I said, there are many different ways to do the same things with operations. And with this mirror rebar segment operation, you can force it to whatever decision it has taken up till that point, you can force it to reverse it. Now, another operation on path which can be useful is if you have a surface macro, which is basically a straight bar and no end conditions. Then if you go to your path operations, there is this operation called generate a bent up rebar. So sometimes when you have these cranked rebars, so this is the bottom reinforcement, but you want to like turn it up, for example, like that. Then if you go to the path operations, you click on the shift key, you will see that you can crank the start and you can crank the end. You can crank them both at the same time. The angle of cranking you can give over here, and you can give a factor which is basically along the length. So if the total length is 1, you might say that 0.35 of that length from the start and 0.35 of that length from the end. You can also give some details for the end conditions, and these can allow you to get some modifications. But if you just say OK over here and go to your path operations, generate bent up rebar, and just select this one, automatically the bottom will stay there and it's going to crank it up towards the ends. So this is a useful operation to have to crank either one side or both sides of your surface macro. Now inside if you go to the list operations and click on the cranked rebar, so this is the operation. If I double click on that, these factors are pretty easy to understand. But if you go to the detail 1 is the start detail and detail 2 is the end detail. So this is the end side, for example. So if I go to this detail and if I change this initial offset distance to, so this is normally equal to the clear cover, And if you notice over here, this one goes up and goes all the way till the end of the slab until about 50 millimeters, the clear cover from the top of the slab. But if I increase this to 200, for example, the height of the slab is 500 in this case. Let's make it 250 and say OK, OK, and OK. You will notice that the cranking with the 45-degree doesn't go all the way till the end of the slab. In fact, it's brought to a distance of 250 from the top of the slab. So you have certain control over the way the point where the cranking will take place, how much it will go into, and also this angle. So for example, if you wanted this to be a very slight angle, then you could also modify that through the operation. So that is more or less a summary of the operations which you can do. We've explained them all, the range operations, the splice operations, and the path operations. You can apply all these to surface macros. Once again, it might be useful to mention that these are only applicable when the underlying rebar is created by a surface macro. Now, you might feel, and because rebar modeling is a complicated subject and different situations require different approaches, so you might feel that I've created my bar through the surface macro, and I've created my splices, and I've done a few, I've done the basics. But from now on, I don't want to use the operations because if you notice, most of the operations are actually quite easily doable through the handles as well. The advantage of the operation is that if you rerun the surface macro, then with the new spacing and the new diameter and the new, basically the operations will also be updated. But the fact remains that most of that stuff can also be done just as easily, if not even easier, using just handles directly on the screen editing directly. So if you feel that on-screen editing is what you prefer, then what you can do is you can do a combination of creating the initial rebar through the surface macro, and then perhaps maybe doing the splicing through that because that's very powerful. But then after that, you might decide to just explode the surface macros, which you can do by just clicking on M, right-clicking and saying macro explode. The surface macro will turn into a normal rebar. And now, of course, you will not be able to apply the operations. But like I said, most of these operations, like conforming to a point or embedding into something, or these are actually just as easily doable through the handles as well. So it's a delicate decision which you will need to take depending on the situation. In some cases, you might want to keep the surface macro, and in other situations, you might prefer that I find it easier to work with the handles. So in that case, you'll just explode the surface macro and continue working with the handles, which is just as valid. So this was a summary of all the operations you can do on surface rebars, rebars generated by surface macros, and like I said, they go through they're either range operations or they're path operations. And then there's some utility ones. You need to refresh the operations. They don't refresh themselves automatically. Once some changes are made in the formwork or some points, you might need to just go and click and refresh it manually. But you have certain nice options over here, like doubling rebars and tripling rebars, and especially things like the conform to formwork objects or splicing. Typically, I would say those are the ones which are difficult to do with handles. They're time consuming. So my personal preference would be do your splicing over here with the surface macro. Do your conform to objects using the surface macro. Do your aligning perhaps very quickly. But then the slight nudges and movements left and right, or embedding it into something else, those you can do either way, whichever one suits you.